Кубентаева С.Н, candidate of Pedagogical Sciences, Department of Computer Modeling and Information Technologies. Discipline: Information and Communication Technologies. Topic of lectures: Introduction to Computer Systems, Architectures of Computer Systems. Plan of lecture: Digital Computer Architecture, Organization of the Digital Computer, Levels of Representation of the DC Architecture, Main Components of the Digital Computer Architecture, Harvard Architecture, Princeton Architecture, Principle of Program Control. Types, formats, and ways of presenting data in the digital computer. Digital Computer Architecture: a set of DC characteristics that are significant from the user's point of view. You can see that the key point here is the way the digital computer is used. A set of general principles of the organization of hardware and software and their characteristics, which determines the functionality of the calculator when solving the corresponding classes of problems. Logical construction of a calculator as it appears to a programmer developing a program in a machine-oriented language. DC architecture. The term architecture: representation of the DC capabilities from the point of view of a user developing a program in a machine-oriented language. Organization: DC architecture related to aspects that are visible to the programmer. Knowing how much memory you can use when writing a program is a part of the architecture, and design aspects are not part of the architecture. Digital Computer Architecture. Interface approach can also be interpreted as disclosing ways of interaction of the central processing unit, CPU, with memory, peripherals, environment, and user. An alternative approach: organization, implementation of these capabilities in specific models. The term architecture determines the capabilities of the digital computer. Computer systems. Digital computer architecture. The term architecture of a computer system, computer, refers to those characteristics of the system that are accessible from the outside, that is, from the program or from another point of view, has a direct impact on the logic of program execution. Structural organization. The term structural organization of a computer system means a set of operating units, devices, and their interconnections that ensure the implementation of the specifications set by the computer architecture. DC architecture. Characteristic: a set of machine instructions. Bit grid format for representing data of different types. Input-output access mechanism. Memory addressing method. Structural organization. Characteristic: control signals, hardware interface between the computer and peripheral equipment, functioning technology. Organization of DC. Structural organization defines the DC device, defines the structure at the level of DC devices and the organization of connections between these devices at the level of hardware interfaces. Functional organization determines the principles of the functioning of the DC, the actual computing processes. Two levels of representation of the DC architecture. Software includes aspects visible to programmers and accordingly programs. Hardware includes aspects invisible to the programmer. Synonyms: structural organization. Software: operating system software, operating systems, utility software, application software, package software, tailored software. Components of a computer system are hardware system, software system, operating system, network system. The operating system software serves as the interface between application software and hardware components. Application software provides instructions that enable the user to perform specific tasks such as creating presentations, document layout, and editing images. Network system manages the way data is transferred from one computer to another and work of different components of a network system. Network connection components: network interface card, modem, phone line or cable, internet service provider. The main components of the CC architecture: computational and logical capabilities, command system, command format, what the command consists of, methods of addressing, purpose and composition of registers. Hardware: structure, organization of memory, organization of input-output, principles of management. Software: operational system, programming languages, application software. Harvard architecture: the multiplication operation took 3 seconds. Instructions were stored on punched tape. 700 kilometers of wires. The data was processed by relay registers, which weighed 5 tons. The main difference is that the command and data lines are physically separate. Dignity: parallelism of transmission, reading and processing of commands and data, which increases performance, but complicates the implementation in comparison with von Neumann's. The characteristics of instructions and data, word length, timing diagrams, address structures are different. Distinctive features: memory for instructions and data, different physical devices. Channels for transmitting instructions and data, different physical devices. Instructions and data can be presented in different formats. Schematic diagram of Harvard architecture. Princeton architecture. Main idea: representation of the program in the memory of the calculator in digital form together with data. Binary representation of numbers. Bottleneck: data transmission line between ALU and OP. Dignity: data comes into memory from a single source. The same is true for output. Limitations: information gets into memory through the ALU without changes, taking up hardware resources. There are two types of memory: data and commands. A system of interrupts and priorities is required, which complicates the architecture. Basic attributes of Princeton architecture. Both instructions and data are presented and processed in the same format. Both instructions and data are stored in the same main memory. Linear memory organization. Machine words are arranged strictly sequentially as a one-dimensional array in a single ordered address space. Each address has a sequential number 0, 1, 2, etc. Sequential execution instructions are extracted from memory and executed sequentially until a special transition instruction, conditional or unconditional, is encountered. Semantic indistinguishability of codes. The internal machine representation does not contain any information that allows you to separate instructions from data as well as data from various types. Flat organization. In the process of computing the topology, architecture, and the list of commands do not change. Battery. A special register and von Neumanns at 40 bytes. Inside an arithmetic logic device, a typical command added a word from memory to the battery and stored the contents of the battery in memory. Electronic implementation. A computer is a fully electronic device. Personal computer and peripherals. Speakers, monitor, CD, DVD drive, system unit, printer, hard drive, mouse, CD, DVD discs, keyboard, microphone, hardware, floppy, heat sink, hard drive, optical drive, RAM modules, processors, motherboard, power supply, system fan, power supply, chip, fan, video card, modem card, sound card, CD, DVD drive, hard drive, motherboard, behind cables, power cords, ribbon cable, extra case fan, computer components inside a laptop. Hardware location may vary each device. Power supply, CMOS battery, CPU, battery, hard drive, thin hard drive, Wi-Fi card, WLAN, motherboard, RAM, keyboard, display. Questions. What are the components of computer systems? What type of software works with the operating system to help you complete specific types of work or tasks? List the network connection components. Using a specific system, computers can convert numbers, letters, and symbols into combinations of ones and zeros. What is the name for this system? Used literature. Thank you for your attention.